Golang is not an object-oriented language, but still considered as a modern language. How is it possible? Golang provides a way to simulate object-oriented behavior. If you are coming from nano-languages, here's a recap for you. Objects are used for encapsulation. By using an object, you don't have to know how it works. In other languages like Java, PHP, object can be defined with the class keyword. For example, they can have properties, and properties have visibilities like private or public, or maybe more. Any objects can have methods, alias functions, and they also can have visibility set. Let's see how can we do the same thing in Go. I've already created a main function. I will create now a new folder called account, and I will add a file into it called account.go, and let's call it package account. We have not covered yet what packages are. In this example we will not cover it, but it will be like obvious when I start to use it. We will dedicate a session later for packaging and how you can organize your code. But let's dig into the code. Okay, then let's create a struct first. Call it ec as a short form of account. It's going to be a struct. As you remember, in the previous episode we discussed structs can basically aggregate different variables and create a function called new. Func new, and it should return the account and return ec. And this is a new instance of our account. If you're coming from another language, we could call it as a constructor of our new struct, or a constructor of a new, let's say in quotes, object. And we go back to the main package and create that struct, initiate that so-called object, account colon equals account dot new. But I'm going to shorten this out as well to avoid variable name shadowing with the name of the package. And I've initiated fmt print line. I'm not doing anything else, just displaying what I've did. Go run dot, and it's just an empty struct. For the simplicity, let's call it bank account, and bank account have something called balance. And if I say balance, let's say it's an integer, we are not dealing with like pennies. Let's run this again, and currently the balance is 0, it's visible. Now let's clear the console. So we've created our first so-called class, but this is only just a struct, nothing else, with a property balance on it. Then let's see what we can do to work with this balance. And let's create a function, add a function. We can add functions to this struct. So if I say func and I say a and account balance, and it should return an integer, and I can say return a balance. It doesn't like that because I already have the balance as a property, so let's do that with get balance and try change it ec dot balance. Let's run it. It displays 0. Add dot get balance, and let's run it, and still display 0. Now let's do a little bit of a trick and change this balance to a small case and a small case here. Come back to our main package and try again with the balance. As you see, it's already underlined, so if I'm running this code, it will break. but the get balance still works. So that was the visibility. In Golang, if you want to do something which is public, it's available outside of the package scope, then you're just going to name it and start the name with a capital case, a capital letter. And if you do that the same with the function and you run it, then I have to change it here as well. It still won't work because it's not exported, it's not public. And I can rename it just to balance now because I renamed this to small case. So if I change it to balance, that works again. Okay, let's try something and changing the balance. Let's see what happens, and let's see if it works. Can I change the balance? And let's say balance int, and instead of return, I'm not going to return with anything, but I will try to change the a balance with balance and try out. I wonder if it will work or not. Clear the console, go run, and it's still 0. Go back to the main function, and before displaying the balance, set a new balance, change a new balance. I called it change balance, and let's try this with like 500. Let's run it, and it's still 0. Yes, it is 0. Let's see why. It is 0 because we already talked about that we have something called scopes, and the scope means that the variable, what I see here, is only available in this function between those curly brackets. So if I'm passing this struct, then it will create a struct, a shadow copy. And if I'm changing the balance on the shadow copy, then it won't change on the struct. So what I can do instead of this, I can refer the balance as a pointer. Let's change this and refer this as a pointer. And if I run again, my balance is immediately 500. So just to recap how we can like create objects, which is not a real object, but like simulating an object. We create a struct, we create a function, we start the function with a capital letter, otherwise it won't be available. Let's try. If I go here and just try with a small caps N, it just doesn't work. So it have to be a capital, it will be exported. And this is what we use instead of a constructor. And we can attach functions to my struct, and these functions can or cannot modify the balance struct, the properties on the balance struct. It can only modify if I pass it with a star, which means that it's a pointer, because if it's a pointer, then I'm going to get the actual instance of that struct which I've created here in the new function. Let's see what else we can do. I can also add parameters here like initial balance, which will be an integer, and when I'm constructing, I can say initial balance equals, balance initial balance. If I try again, I have to save that. I have to provide an initial balance. Let's see, 100. Let's comment this out. This is 100, and it still works. If I changing the balance to 500, then it's 500. Let's add another function like pay in, pay in, or I can call it deposit. Just use more financial terms. And balance, let's call it deposit. And balance equals a.balance plus deposit. That's a long form. Let's run it. That's 500. Instead of balance, use deposit. Then it's 600. I can use a short form if my memory is correct, and I can see plus equals deposit. That's a short form, and it's 600. Now do a withdraw. With a minus. And let's try adding a deposit. Let's first display the balance here, here and here. Adding a deposit 500, then withdraw 200 and display all the balances, and 100, 600 and 400. So we have our object, which is not a real object but code object. We have something what we used instead of constructors. We have the visibility. Only two visibility exists here in Golang, public and private, or we can call it exported and non-exported. Just the same for the struct as well. And if we use a pointer, we call it pointer receiver function, we can modify the struct. If we are not, we cannot. It depends on the use case. Alright, that's it for this episode. In the next episode we will go even further, and we will see how interfaces working in Golang. This will be used for abstraction and reusability. See you in the next episode. And don't forget to subscribe to the channel if you want to get a notification when I'm uploading the next one.